Which of the following is the oxidation number of F equal to 0? A. Calcium fluoride. B. Carbon tetrafluoride. C. Sodium fluoride. Or D. Diatomic fluorine. Here's the rule applicable to this situation. The oxidation number of fluorine is -1, except in the diatomic fluorine molecule, where its oxidation number is 0. Therefore, the correct answer is D. In all the choices given, the oxidation number of fluorine is -1. In choice D, it is 0. If you want to understand the basis for this rule and learn about other exceptions, continue watching. Oxidation number is defined as the charge of a monatomic species. For example, the oxidation number of a fluoride ion, as in choices A and C, is -1. By now you should be able to recognize that the formulas given in choices A and C are for ionic compounds. The fluorine in these compounds exist as monatomic ions with a -1 charge. When we refer to something as a monatomic species, we mean something that has only one nucleus, such as a fluoride ion, or a neutral fluorine atom, which would have an oxidation number of 0, or the cation formed if a fluorine atom were to lose 2 electrons, which would have an oxidation number of +2. Note neutral fluorine atoms and monatomic fluorine ions with a charge other than -1 are not found in naturally occurring substances, the kinds that are stable enough that can be kept in bottles. That's why they're usually not mentioned in the rules for assigning oxidation numbers. When an atom is part of a polyatomic species, then strictly speaking the atom does not have a charge. Charge is defined only for the entire species, so in these cases, the atoms are assigned fictitious or apparent charges. The oxidation number of an atom in a polyatomic species is the fictitious charge, which is determined by the ownership of shared electrons to the more electronegative atom. Fluorine happens to be the most electronegative element. This means that when a fluorine atom shares electrons with another atom, other than another fluorine atom, it is always assigned ownership of the shared electrons. As a result, fluorine in these cases always ends up being assigned an oxidation number of -1, as in choice B. In a carbon tetrafluoride molecule, each fluorine atom shares electrons with the carbon atom. Ownership of the shared electron is assigned to the fluorine atoms, so each fluorine atom is assigned an oxidation number of -1. Thus, the carbon atom appears to have lost 4 electrons, 1 to each of the fluorine atoms. Therefore, the oxidation number of carbon in CF4 is +4. In the case of a diatomic fluorine molecule, F2, each fluorine atom is sharing electrons with another fluorine atom. Obviously, neither atom is more electronegative than the other, so ownership of the shared electrons is divided equally between the 2 atoms. As a result, neither atom appears to have gained nor lost electrons. The apparent charge of each atom is 0, so the oxidation number of fluorine atoms in diatomic F2 molecules is 0. In general, all the atoms in a pure elemental substance are assigned an oxidation number of 0.